Now let's look at authorization attacks. What is a user allowed to do? And one of the simplest types of authorization attacks is what is known as a path or directory traversal attack, where you break out of some document space by using relative paths, so the dot dot slash attack, right? So normally your the file that you're accessing is some file in a particular directory. But what we're seeing here is that now we're accessing a file that is going back to multiple levels up in the file hierarchy to go and access a file from root slash etc slash password. And you can do this directly with a dot dot slash, or you can, encode this or double encode this and even obfuscate it so that, it doesn't immediately look like a dot dot slash attack. And filtering out dot dot slash is not sufficient. A similar type of attack is what we refer to as forceful browsing, where you attack the implicit assumption that the user will always use the intended path to access some resource, right? Go through the links that are provided on a web page. But there's no reason why an attacker would have to do this. What you can do is modify the file names or the parameters that are provided and see whether you can jump to some resources that would normally not be available through the intended path. So in this example, we see that there is a calendar for a particular user, and the calendar has some, in this particular case, a date. And what we can do as an attacker is try and see whether we can also maybe get access to somebody else's calendar and maybe for other dates. So we tamper with some of the elements that we see here, okay? Known as forceful browsing. And surprisingly, sometimes you get access to really sensitive information this way. Another thing that we can use is the automatic directory listing. Okay, so in this case, the browser returns a listing of the directory if there's no index.html file, and that may in itself already expose sensitive information. So what we've seen so far is parameter manipulation, right? So you have the situation where the untrusted client's information is simply accepted by the server, and therefore the client could try to modify a query, for instance, changing the user ID or maybe changing the type of information that you're asking for. But maybe that is not successful because you may not have access to certain things. So what you can also do besides parameter manipulation is parameter creation. In that case, we add additional parameters. So since these client-side parameters are blindly accepted, what we do here is we add admin equals 1 in the hope that maybe we get elevated privileges to obtain information that we would not normally be able to get. Okay, parameter manipulation and parameter creation. And in this context, it's useful to look at the register globals directive of PHP. So register globals, the register global directive was something that was set by default in PHP. It's no longer set by default. But it basically means that all the parameters that are provided by, so your get query and the cookie information and all sorts of other things um, um, become global variables, and that is very handy. So let's have a look. In the example here, we have some PHP code that uh, has a get parameter password, and it tests to see if that password is secret, and if it's secret, it says admin to true, right? So you have some hidden password that nobody knows. In this case, it's secret, and only if you know that the value of admin will be true, and if you're the admin, you can do certain things that you wouldn't normally be able to do. Now, If register globals is set and all the parameters that you provide are uh, also global variables in your PHP code, then it may be useful to try to get access to the the administrator privileged information by simply adding admin equals one in the query, because this is now a global variable, and that means that you may still not know the secret, but by the time you get here, admin hasn't been initialized yet, so it will be the value that you provided, admin equals one, and therefore you still get access to that privileged information. In other words, if this is the case, all the variables should always be initialized or sanitized along every path. In general, all variables should be initialized or sanitized along every path. But now, in this particular case, it becomes even more pertinent because you may get initialization that you don't see in the code itself. Now, like I said, register globals used to be the default option, and that's changed, for years already. So it's ever since PHP 4.2.0. But you may find that certain applications depend on this. So some older applications may still have register globals on. So check the php.ini script or htaccess. Okay. And some PHP-based applications solve this by adding code that does something similar to register global without having them turn on the register global's behavior. Now, here's a very brief intermezzo where I want to say that sometimes misconfigurations, so unfortunate combinations of programs, may lead to problems also. For instance, a good example and a classic example of this is the combination of FTP and web servers that are run on the same host. And if then the FTP server may upload files that are then requested via the web server, what you may get is that maybe some of these programs are executable, and then you could perhaps execute them via the CGI mechanism, or you could have the situation that server-side include mechanisms will lead to the execution of commands. And this is, just a simple bridge towards the notion of server-side include that we're going to talk about very shortly. But first, let's talk about this in general, because now we're talking about command injection attacks. We've had authentication attacks. We've briefly looked at some authorization attacks. And now we're moving into the domain of command injection attacks. And the problem in general is that you don't validate user input sufficiently. And therefore, you get the problem that some commands are that the attacker controls are being executed. Okay. And how this is done depends on the language that we're dealing with. So for PHP, it works a little bit differently than for other languages. But the point is that you're using some of this, untrusted and not properly sanitized external input to create essentially commands that are executed. And for instance, for certain languages, it could be used in a system directive or in an eval or a popen or include or require. Now, we're going to look at some of these examples in a minute. But first, as usual, we will start with the most basic attack of this sort. So here we have, say, a CGI program that, as part of its execution, is going to execute a grab command over a file. Okay. And some of the user input is used as a parameter. So it's untrusted and unsanitized user input. And what the CGI program is going to do is it's going to execute system, and then what command will it be executing from the shell? The grab command, right? So grab with the untrusted user input, and it because that's going to be the keyword that we're going to look for in this file phone book text. Now, what is wrong with this example? Well, even if you think about this for just a minute, you'll already see what the problem is, right? So the user command, the user input, is not sanitized. So you can put anything you want there. right? For instance, what you could put there is foo dot semicolon and then mail the attacker at evil.com, the etc password file, and then rm. What this will do is it will simply be added in this command. So you will grab for foo in dot, who cares? Then it's going to mail the etc password file to hacker at evil.com. And then for good measure, it will also remove your phone book, so your existing phone book. Okay. Um, so it's doing two really bad things in one go. Now, how do we fix this? Well, we could try to fix this by, maybe putting the user input in quotes, so it no longer has this the same way of creating the command line. Is this going to help, or are there still problems? Well, let's think about this for just a minute longer and see how we could manipulate the user input such that it still creates a malicious command. Well, what we could do here is, yes, exp is in quote, but we can also provide quotes ourselves. So if we provide, the quotes at the beginning here, foo dot, and then have the same commands that we had earlier and end with a quote ourselves, double quotes, all of these are double quotes. Then and we plug this into the command that we see above, then we still have the same command. We can steal the password file and delete the txt file. So what can we do to prevent this? Well, maybe we can do yet another thing. Okay, so implementation number 3, where we still use system, but now we have grep as a separate string, -e, so the expression that we're going to be using in the grep command is the next argument. So, and that's a user input. And the final argument for grep is going to be phonebook.txt. Now, think about this. Could you still exploit this? Okay. I'll give you, maybe you should pause the video and think about this carefully. It's definitely not such an easy example. So here, the same problem that we had in the previous two cases no longer exists. Okay, what you're doing is executing the grep command, similar to how you would use execve, the system call execve, and therefore you're no longer parsing any shell command line arguments. Okay, so that's great, and this is a lot more secure. So now let's look at a slightly more complicated example, and this is what I referred to earlier as server-side includes, or SSI. And if you want to know more about server-side includes, here's a link to your Wikipedia page on this. But what it really means is that you have a really simple interpreted scripting language that runs on the server side, and it's really simple. But it has a number of directives that allow you to add some dynamic content to your web pages. For instance, you can execute commands, or you can include certain things. You can do a config or an echo, a number of things that would help you to create more interesting commands. So the SSI, the server-side includes, are introduced with, a comment tag and then an element such as config, echo, include, or exec, and then an attribute equals value list of arguments there. Okay. Now, if a user, an untrusted user, is able to determine the contents of a web page, right, it also means that that user is able to execute arbitrary commands. So if any of this might be used in one of these server-side includes, to configure one of these server-side includes, well, then you might have a security problem. Okay. So let's have a look at an example where we have the same code that we introduced a while ago in a previous video. Okay, this was a really simple and dumb program where I already indicated that this is a problematic case. It's the feedback page. So we have a feedback page, and the feedback page contains a little bit of PHP code that obtains the name and a comment for, including on the web page some, feedback. Okay, and the way that worked was that once you receive the name and a comment, it's a post command that you're using. The the name of the comment will be added to the feedback.html file. Where is it? The feedback.html file is opened here, and you add to that. So one additional thing that you add to the file is whatever the name is said, and then whatever the comment is. Okay, you close the file and you include that feedback file. Okay, so you actually see all the feedback, including your own, at that time. Now, why is that bad? Well, for instance, because you can include these server-side include directives. Okay? For instance, you can add a comment where the comment contains something like exec and then the command pat etc password file. Okay, so what that will do is it will execute the etc password file and have that in your feedback.html that is immediately included. Okay, so the SSI directive will be automatically executed because it's executed when you're serving this at the web server side. Some related badness is still possible in many PHP implementations, in PHP applications. Okay, when they have the allow URL open directive to be used. In that case, if you have the allow URL open directive set to true, you will allow URLs to be used when you're including a file with the statements include and require. Okay. Now, that is all in principle, that's all fine, as long as this is not susceptible to user input. So, because if users may provide this data, they can actually determine where the file comes from. Okay, for instance, in this case, we have an application, a PHP application, which has an include path / includes, and that means that everything that will be included from that include path. For instance, in your code, you may have something like include from the include path library.php. Okay, that is all good, and the library.php might do also an include of the include path of math.php. Now that's all good as long as you go to the main app.php. However, if you go directly to the library.php path and you set the include path to http www.evil.com, and this is used as the include path in this library.php, then it will actually obtain this code and run this code from another website. Okay? This, mind you, this assumes that the URL, the include path, can be set in this way, right? In other words, this would be the case, for instance, with register globals. Now, unfortunately, this option, the allow URL open option, is still on by default in many sites. So this is something that you can definitely still scan for, and with some hope of success. We can also use injection in HTML tags to change the behavior of a web page that you have served from your server. Okay, for instance, you can add forms to collect, the credit card details of a user, or maybe some password of a user, or you can inject iframe tags to access another website's information. Right, so maybe a malicious website. For instance, what you can add in the comments section on the previous example, what you could add is an iframe that comes from some evil site with some parameters, and you make it as small as possible and as hidden as possible. Okay, this will simply be interpreted by your browser as being legitimate HTMLs, and therefore the iframe will be the content for that iframe will be fetched. Okay, so why would this be interesting for an attacker? Well, for instance, you could use it to serve malicious code to the user. A browser exploit could be hidden in that code, or it may be possible to bypass this single origin policy and then obtain info from the page that includes this. Nowadays, if you do this, you'll actually get warnings from Google, right? So if Google actually finds this, it will display a warning saying this site may harm your computer. Iframes have also often been used to incorporate some, popular website on a page that is really run by a malicious user. So in this particular case, there's a page that is run by an attacker, so from the attacker.com domain, and it has an iframe that includes the Gmail web page, right? So what the attacker is hoping for is that the victim will type his or her credentials here, and then there is a keylogger operating in the background that records the keystroke, so the username and password, and sends it to an attacker. So preventing command injection is really a matter of sanitization. So you should not trust input from an external source. So you should not trust inputs from an external untrusted source when you're composing a command string. And therefore, you need to do sanitization. And many languages have primitives for this built in. For instance, for PHP, you can have strip tags to return a string without HTML tags. And for PHP, HTML entities will translate all special characters. Escape shell argument will add single quotes around a string and quotes or escapes around any existing single quotes. Okay. And you have escape shell command to escape any characters in a string that might be used to trick a shell command into executing arbitrary commands. And here's an example of those characters. Okay. So this is what I was going to say about command injection, except that there is one important class that is still left, and that is SQL injection or SQL injection, wherever depending on who you talk to. And that is the topic of the next video.